one other thing I do want to show, because I think it's actually really cool, is testing.
Yeah.
I think DevTools and the testing story both fall out of the same like core architecture, and like that's really cool because you can do really interesting things with testing that aren't possible in other frameworks. So there's two types of testing in Foldkit. There's story testing, which is testing the update loop, and then there's scene testing, which is testing kind of still testing the update loop, but it's through your view. So like story is like the state machine, and scene is like I click this thing and then I see this other thing. So story testing, if we just go to like a simple one here.
One is more behavioral focused and does tests on the shape of the model, I would say. And the other one is more like on assuming that things that get rendered and then what happens when things get clicked, right?
Exactly. Yep.
Okay.
Story testing is you're asserting on model state, and you're also asserting on commands and then resolving commands. So in this case, we provide our update function. We say that this is the initial model. We send this message through update, and then this command happens. So like a delay reset command is dispatched. We have to say what happens because this is a side effect. And then we just expect that the model count is 0.
So are updates always synchronous?
Update is synchronous. Yeah, pure
and
synchronous.
Commands are the things that can be effectful or asynchronous.
Yep.
And in this test, then, when you say, okay, click reset after delay, is the update message, is the message. Then a command gets issued, which is delay reset. If delay reset takes time, do you integrate with like the effect test clock or anything like that? Because like, you could imagine. So if commands are asynchronous, then I assume that resolve in this case is asynchronous. Like the story is returning a promise here, or
no, this is synchronous. So this is just like, this isn't mocking anything. This is just a command with the tag or the name delay reset showed up, and you need to resolve it for the test to continue. And the resolution is this message. So
I see.
Basically, you are faking up the execution of the effect by just asserting that after
this is the message.
Triggering the message, the update gets that command, and then instead of having the runtime execute the command, you'll say something like, hey, take this command and make it so it ended up with this completed delay reset. Is that correct?
Yes, exactly. Yep.
It would be interesting to have the ability to, I don't know if this is possible or desirable, but it would be interesting to have the ability to, like, maybe this is a scene test and not a story test, but it would be interesting to have the ability to like rely on the actual code you've written for resolution from your from like the for that particular command, and then you could integrate with like effects testing utilities to deal with time, for example, like the test clock you could use to test like time-based interactions, etc. I don't know if that's I don't know if that fits in with the story testing or if that's a scene test, but could be interesting to think about.
Yeah, that's super interesting. I honestly haven't thought about that at all.
Basically, instead of like mocking the engine, letting the engine actually execute the comments, but providing to the engine like a test clock, deterministic random or whatever, and then using the effect testing utils to adjust and assert that eventually something will happen. So for example, I would say that instead of saying story.command.resolve, you would have something like story.command.expect completion with, and you provide you expect that completed delay reset happens, right? Is that what you meant, Maxwell?
Yeah, the only tricky part here that I can think about is that because the story is a synchronous thing right now. You don't have the ability to, for example, like fork the execution of the command into a fiber, which is required in the effect runtime to be able to utilize the test clock. Like you need, in order to be able to utilize the test clock, you have to fork the program that advances time into one fiber and then advance the test clock in the other fiber, because otherwise you'd end up in a situation where if you have one fiber, you do the thing that advances time never advances, and then you try to advance the test clock, but you never make it past this point. So that's like you just have a dead, you just totally like blocked.
Time never passes.
Right. Whereas like if you do it properly, like in an effect test that advances time, you fork the program that advances time into a separate fiber, you advance time, you join the program back, and then like it sees that time has advanced. So like since story testing right now is synchronous, it probably doesn't fit well currently, but could be something like interesting to think about for like more robust like testing of the command logic. Like if you want to know, if you want to actually test like this is the logic I wrote for my command, I want to test this logic as opposed to just the messages that are coming in.
I would say that both of them make sense. They're probably like target to different kind of purposes. With the story, you are correctly checking just the logic of the update method itself, that you are just checking that the update function behaves and respond as you expect. Whereas there needs to be another primitive, like for example app tests or whatever, that actually spawns up like a real engine for the Foldkit UI, and that will instead like attempt to execute your application with a real engine, but with kind of deterministic or test services instead. So that ideally in a test world, I would imagine that you would have both of them, both type of tests, because with the story you test that the logic that's coded by the model is correct, that behaves correctly, that does not sending maybe order of events correctly move the state machine, because again it is a state machine in the end, to the correct state, whereas instead the other kind of test is testing the state machine but feeding the state machine as well the actual side effect implementation, so that you can test that the interaction between what you already have tested and your side effects is correct, because you expect those to output correctly. And same goes again with regular effect testing. I imagine you can test the actual implementation of just the command body providing test utils, I would say. Yeah, that's interesting.
Do you want to look at scene testing real quick?
Yeah, tell us about scene testing. I'm interested.
So scene testing is testing through the view. I'm going to scroll down to the complete scene here.
That's nice.
So very similar. Instead of just giving update, you say, here's my update, here's the view. So like this is your actual view. Here's the starting model, and then do some stuff, expect some stuff. We have some commands, and then at the end we do some more expects. Another thing that's interesting, I think, and unique to Foldkit testing is that you have to do this. Like you have this. If you don't include this, your test will not pass. So like every command that is dispatched must be acknowledged. Even like you know, my list box in Foldkit UI needed some command to like do some rendering thing. Like that will show up in your scene tests, and it sounds a little bit weird at first, like, oh, I'm testing this other thing, but now I have to deal with like resolving this command for some Foldkit UI component. But it means that you can trust your tests to tell the truth about what's happening. Like you see your side effects in your tests by construction instead of like having to be super disciplined. Actually, I listened to the Dylan Mulroy podcast with cause and effects earlier today. He said something like discipline doesn't scale.
Mm-hmm.
Like that's the thing, right? Like I want to look at a test and know that like I don't have to trust the test author 2 years ago that wrote it to trust the test is kind of doing what I expect.
I think like on a global commentary, like in the age of AI agents writing tons and tons of code, like this type of mindset is very useful. Like, because you get like one of the things that I don't think gets talked about enough, or maybe I just don't see it getting talked about enough, is how fast code drifts now. Like, like we are writing code at a much faster pace now. I think almost everybody who's writing code and leveraging AI has probably experienced how fast code drifts, how much cruft gets left behind. Like the agents are really good at writing code. They're not as good at removing code. Like, and so and that's annoying to me because then like as the human in the loop trying to like keep up with reviewing and things like that and making sure that the app is behaving as it should, it gets really annoying. So like having the ability to be sure like, okay, my test is testing every aspect of like this particular piece of my application is something that I think is desirable.
I also love how these kind of like tests that are very kind of like readable, I would not say declarative, but they are very readable. You read them, you basically see a story, a scene, you see what you expect. And I really like them because, again, also like the LLM, when you change idea over a feature or something, what they usually do is that they change the test code and they just swap whatever you had before as an assertion with an assertion that now should not happen, which is usually what you won't have in your code base forever. And like having a test format like that really tries to help the AI not do that, but instead assert what should happen and not what should not happen. I really like that. I have like a couple of questions, if that's not a problem, about this scene. When you say that if you go down and you said scene dot expect exact, and then you say basically what command you expect, right? And then you say command dot resolve. Is there also ways to say things like I also expect that no other comments are issued alongside those?
So there is, let's see.
There is a list. Oh, nice.
So these are all the, let's see.
To be absent,
expect none.
Nice.
So you can say like I expect this this command. I can say I can expect this command with this particular payload. I can resolve many commands at once.
When you resolve them, you can also like resolve them with specific payload as well. Because for example, let's say that the update triggered like 2 times the same fetch weather command. Could also say resolve this one, but not the other one.
Yeah, so you have to resolve all of them, and typically you do that with resolve all. Like you would say, yep, 2 happened, resolve with this, resolve with that.
If a command fails, you would still resolve the command, but with the failure message?
Yes. So unlike Elm, Foldkit programs can crash if you do something that causes a crash. But since we're using effects, the idiomatic approach is like do things safely and return errors as values. So like I think we do that. Yeah. Failed fetch weather. So where's our failed? The zip code's empty, fail. If our HTTP stuff fails,
And from the UI, from the engine's perspective, is there a real difference between the failure message and the success message? Because when you define the command, I think I remember seeing like a success and failure thing, maybe, or maybe I hallucinated that in my head.
No. You saw that. No, the runtime doesn't know the difference. All the runtime sees is where's our command? Yeah, all the runtime sees is there's a command with this name. These are the arguments that are required to run the effect. And then these are the messages that it could return. So like if we remove this, like it's going to be like, yeah, sorry, that doesn't work because you're not telling me that this returns a fetch or a failed weather command.
So is it a variadic argument as the last argument, or is it like a success message? Okay. That's why I got confused. I thought this was like specifically like this is the success case, this is the failure case, but you could just keep going theoretically. Got it. Okay.
Yes, and that's also like, and again, that M function you had before is basically just an alias to creating like we said before things like tag struct. So potentially one could also use things like schema tagged structs, for example, tag struct, schema tagged errors for the message shapes. Would that work or not? Because it is interesting because I was thinking that things like you know how schema tagged errors or basically affect errors from the data module, but in this case you embraced schema, which I loved, so that's why I was speaking about schema tagged error. They capture the code location where the error has been raised, so it could be also interesting if you have messages in the UI and the dev tools that are of the error type. It could be interesting also to see like, hey, when you click on the message tab, you see things like that's the stack where this error object has been constructed, which will point probably to your common definition. But it is nice because if you have domain errors, then they can become immediately messages, right? As long as they have a tag, right?
Yes. Yep.
So that could work like you can have your services with your domain errors and you can use your domain errors as UI messages as well.